Welcome to Lesson 3 on Proportional Relationships. Today we're going to talk about the constant of proportionality. Isn't that a great word? And we'll be using this quite a bit throughout the rest of this lesson. And the constant of proportionality, we're going to find out, also has other names. So let's first start with this definition. Two quantities are blank if the ratio between the quantities is blank. So let's fill that in. Two quantities are proportional if the ratio between the two quantities is constant. So we're going to explore what that means. In our first problem, it says Mario travels 180 miles in 2.5 or 2.5 hours. If Mario travels at the same rate, and that's important because it means it's constant, how far can Mario travel in 5 hours? So they've now given us enough information that we can make a proportion. So we've given 180 miles in 2 hours, and they were asking us how far can he travel in 5 hours. So the question we're trying to answer is how far can Mario travel, meaning distance, in this case miles, in 5 hours. So let's set up a proportion to do this. We have miles, and we're given hours. And by the way, I prefer to put my labels out front so they're not in the way of my numbers, but many people put the labels behind the numbers, and that's okay. So I'm going to start with 180 miles in 2.5 hours. So that's the beginning ratio. That's what they've given us. They went on to say, to ask how far can Mario travel, meaning we don't know the miles, so that's our unknown. But they did give us 5 hours. So now we have a proportion that we can cross multiply and solve. Once again, it doesn't matter which wing you do first. My personal preference, as I mentioned before, is to start with the x. So if I cross multiply 2.5 times x, I'm going to get 2.5x. The body reminds us to write the equal sign, and then 5 times 180 would be 900. Now we're going to divide by 2.5 on both sides. And let's pause the video and use our calculator. And hopefully we all have 360. And what do we find? Well, we found 360 miles. Number 2 says using the information about Mario's rate. So we're going to tie in what we learned in question 1 to this. It asks us to complete the table below. And I'm noticing that they mentioned hours first, and this is usually whatever they mention first, we usually refer to as the x values. And then in the table I see miles. So in the table the second value is usually the y values. And they mention for us to use the information above. So we've noticed that this 2.5 hours before, and it was paired up with 180 miles. And after we used our 5 hours, we found out that Mario could travel 360 miles. So now we have the beginning of a table. But we have 3 spaces we need to fill in. So let's start looking for patterns. Let's see if we notice anything when we go from 2.5 to 5. Well, I'm noticing if I took 2.5 and I added 2.5, that would give me 5. And I'm also noticing if I add 2.5 to 5, I'm going to get 7.5. And it looks like this pattern continues. If I add 2.5 to each of the x values, I do get the next x value in the table. So we've established that pattern. Because there's a pattern with the x values, we're going to assume there might be a pattern with the y values. So let's look at this. Let's see if we can see a pattern with the y values. So if I start at 180 and I go to 360, that would be adding 180. And since my x values have a consistent or a constant pattern, we're going to use that and assume that there's a constant pattern here. I'm going to add 180, which would be 540. And then to 540, we're going to add another 180. And that would be 720. And then we're going to add another 180, and that would be 900. So the final question asks, how many miles does Mario travel in 1 hour? And it says, explain your solution. So we can go back to the beginning with the information that they gave us. Now that we know it's a constant rate, we can use what they gave us at the beginning and say, well, we can travel 180 miles in 2.5 hours. And what we've learned in the past, if I want to find a unit rate, I'm going to take the top value divided by the bottom value. In this case, it's 180 divided by 2.5. And when we do that, we get 72. So 72, we want to go back and write meaning to this. We go back and look at the top label is referring to miles. And then we look at the bottom label, per hour. So Mario can travel 72 miles per hour. So now let's go on to the definition of what the title is. You notice that it says here, constant of proportionality. And the word proportionality has proportional in it. So the constant of proportionality is the value of the ratio of two proportional quantities. And we can have more than two proportional quantities, but whatever ratio, we keep coming back to that constant rate when we simplify, is called the constant of proportionality. The constant of proportionality is represented by the equation. And let's write this equation. It is K equals YX. And we'll discuss this further in a minute. So it says it is represented by the equation K equals Y divided by X, where Y represents the Y values in a table or graph, and X represents the X values in the table and graph. Now you may have noticed this K kind of seemingly magically appears, and we want to know where that comes from. Well, we refer to the K as the constant of proportionality as the K value. So whatever we come up with as the value of Y divided by X would equal K, which also means the constant of proportionality. We also sometimes refer to this as a unit rate. So now let's practice and see what this looks like with the next table. Problem number 4 says, examine the table below. Describe the patterns that are true. So I'm noticing that the X values are all in feet and the Y values are all in inches. And if you're familiar with a standard school ruler, there are indeed 12 inches in every foot on a school ruler. So I'm noticing it asks us to place the Y values over the X values. So I'm going to start with 12, and I'm going to put it over its matching X value of 1. So I've created a ratio, 12 divided by 1. and that's going to give me 12. I'm going to go to the next pair, and I see 24 as the y value. Y has to be on top, compared to its matching x value, which is 2. So 24 divided by 2 would be 12. So I'm going to have you pause this video and complete the rest of the table based on this first two examples. All right, if you need to make any corrections, go ahead and do so. A says, how do you know that the number of feet is proportional to the number of inches? Well, we know that the number of feet is proportional and because all of the y x ratios equal the same number. So 12 is the constant of, I'm going to try to squeeze this in, proportionality. The last question today says, using x, which is the number of feet, how do you find y, which is the number of inches? Well, you may have also noticed this pattern. If I take 1, keep forgetting to change to my pencil, 1 times 12, you get back 12. 2 times 12, you would get back 24. 3 times 12, you get back 36, which means I'd just take that times 12. So using x, the number of feet, how do you find y? Well, you multiply it, the x values, by 12 to get the y values. And in our next lesson, we're going to explore how we can use a new equation, which looks like this. Y equals kx. And what that means, if we want to know our y values, we would use our k value, in this case it was 12, and multiply it times the x value. So in this case, our equation would be, to find all the y values, we would take 12 times all of the x values. See you next lesson.